Hi, Dr. G here. We're going to go through a couple of examples of how to solve absolute value inequalities. So I want to remind you that the absolute value of a real number is the distance that that number is from 0 on the number line. So if the absolute value of the number A is 2, that means the distance away from 0 is 2 units. The distance that A is away from 0 is 2 units. So that means A could be 2 or it could be -2 because there's 2 directions you can go. Just go 2 units to the right from 0 and you'll be at +2. If you go 2 units to the left from 0, you'll be at -2. So if the absolute value of A is equal to 2, then A is either -2 or +2. So now we're going to look at inequalities. So if we have the absolute value of A is less than some number K, what that means is that the distance between A and the number 0 has to be less than K units. Okay? The distance between A and 0 is less than K units. So what does that look like on the number line? If you go K units to the right or K units to the left, where do you land? So if you go K units to the right, you land at the number K. But if you go to the left, you land at the number -K. So if the distance between A and 0 is less than K units, A has to be somewhere in between those two numbers, -K and +K. So as an inequality, we just say A is, or we say -K is less than A and A is less than +K, or A is greater than -K and less than +K. And in interval notation, we write it like this, with round parentheses at the numbers -K and +K, because we're not including those two numbers. So A is strictly in between them, is any number in between them. All right, so what if we have a greater than? So the absolute value of A is greater than K means that the distance between A and the number 0 has to be greater than K units. All right, so on the number line, let's draw it again. So K units to the right, K units to the left. So -K and +K. So where is A? If the distance between A and 0 is greater than K units, A is outside. It's out there greater than +K, or it's out there on the left, less than -K, because the distance has to be greater than K units away from 0. So as an inequality, we have to write it as a compound inequality. So A is less than -K or A is greater than +K. We can't say and, because there's no way a number can be less than -K and greater than +K. There's no way that A can be both of those things at the same time. So we have to say or. And then to write it in interval notation, we actually have to take 2 intervals. So the one on the left is all the numbers between -∞ up to -K, but not including -K. And then the other interval to the right is the numbers between +K and +∞, but not including +K. And then we join these 2 intervals with a symbol that looks like a U, and that means union. So the solutions to, all the solutions to that inequality, absolute value of A is greater than K, are all the numbers in that first interval along with all of the numbers in that second interval. Okay, we take those two intervals and join them together, and we call that a union. That's all the solutions. All right, so let's look at some examples. So the first example says, solve the absolute value of 5x minus 6 is less than or equal to 4. Then we have to graph the solution and write the solution in interval notation. So this is less than or equal to. So the absolute value of something is less than or equal to 4. So that means that the thing inside the absolute value is squeezed in between -4 and +4, because that distance from 0 is less than or equal to 4. So we can take away the absolute value and rewrite it as a compound inequality. So the thing inside, which is 5x minus 6, is greater than or equal to -4 and less than or equal to +4. And we write that as a compound inequality where we don't have to use the word and, it's just implied. And then to solve this for x, it's just like solving an equation, right? So we add 6 to all three parts. And so we get 2 is less than or equal to 5x is less than or equal to +10. And then divide each of the three parts by 5 to get x by itself. And we get x greater than or equal to 2/5 and also less than or equal to 2. So x is in between 2/5 and 2. And because of the greater than or equal to and the less than or equal to, that means that x could be equal to 2 and it could be equal to 2/5. So let's draw that solution set on the number line. So we mark 2/5 and 2 on the number line. And so x could be anywhere in between, or it could be equal to either of those endpoints. So we're going to use closed circles, solid dots at the two endpoints, and then connect them with a line. So that says any number in between 2/5 and 2, or it could be 2/5 or it could be 2. And then in interval notation, instead of a round parenthesis, because round parenthesis says we're not including this number, the endpoint, instead of that, we're going to use a square bracket because we want to indicate that we are including both of those endpoints. So square bracket 2/5, comma 2 with another square bracket. So the square brackets indicate we're including that point. All right. So that was a less than or equal to. We had to squeeze the thing inside the absolute value had to be squeezed in between a positive number and a negative number. So now let's do one with a greater than or equal to. So this one says, solve absolute value of 2x minus 3 is greater than or equal to 5. We're going to graph it and write it in interval notation. So now the distance between the thing inside the absolute value and the number 0 has to be greater than or equal to 5 units. So that means we're outside. We're going away from 0. We're outside the interval between -5 and 5. So we do have to use a compound inequality. We have to write two inequality statements and connect them with a word. So either 2x minus 3 is less than or equal to -5, or 2x minus 3 is greater than or equal to +5. And we had to connect, when you have a compound inequality, and you have to write it as two separate inequalities, you have to connect them with a word, either or and. And if you can't remember which one it is, just think about it sort of logically. Can a number be less than or equal to -5 and greater than or equal to +5 at the same time? Because if you use the word and, that means that both statements have to be true at the same time. So there's no way that a number can be less than or equal to -5 and greater than or equal to +5 at the same time. So that means we have to use the word or to connect these two. All right, so now let's solve each of them separately. So the one on the left, I'm going to add 3 to both sides, and I get 2x is less than or equal to negative 2. And then I can divide both sides by 2, and I get x is less than or equal to negative 1. And then the other one, let's do the same thing, add 3 to both sides, and we get 2x is greater than or equal to positive 8. Then if we divide both sides by 2, we get x is greater than or equal to positive 4. And we have to connect them with the word or. So we started with an or, so we're not going to change it to and. And clearly we can see there's no way the number x can be both less than or equal to negative 1 and greater than or equal to positive 4. There's no way that and makes sense. So the only word that makes sense is the word or. All right, so let's draw the number line. So we've marked off negative 1, positive 4. So we're going to include negative 1 because it's a less than or equal to, and then we draw the arrow down to the left, down toward negative infinity. And then we're also going to include positive 4 and draw the arrow going up because all the numbers greater than positive 4 are over to the right. And then to use interval notation, we are going to have 2 intervals. So the one on the left, the largest number is negative 1, and we're going down to negative infinity. And notice we have a square bracket next to the negative 1 because we want to include that number. But we have a regular old round parenthesis next to the negative infinity. And that's because we never include a negative infinity or positive infinity in our intervals. We're always going to have a regular old round parenthesis next to one of those symbols. And then the other interval is square bracket positive 4, comma, positive infinity. Because we're including positive 4 and all the numbers greater than positive 4, but we're not including infinity. And then we have to connect them with a symbol. And again, the symbol is the union symbol. So that's our answer in interval notation. So the difference between less than and greater than when you're doing absolute value is, remember that absolute value means the distance. So the distance that the number inside is away from 0 is less than some number means that you're squeezing it in between a negative number and a positive number. But if the distance, if it's a greater than or equal to, then the distance between that number inside and the number 0 has to be greater than a certain number of units. Then you're outside. You're going away from 0. So you're going to get 2 inequalities. And they can't happen at the same time. So you got to put an or in between. All right. So you'll see these again. And these are going to be on the first exam. Good luck.